Good morning, students. Chapter 4, Moving Charges and Magnetism. Yes, from Oersted's observation, it was clear a current carrying element produces magnetic field. So now you may ask the question, sir, if there is magnetic field, then what is the amount of magnetic field? How to find magnetic field due to current? Okay, so yes, that relation is given by Biot. What is theory title? Magnetic field due to a current element, Biot law. Biot law, scientist name. Okay, so what is Biot law? What important theory in this lecture? See here. We have one conductor. Okay, of this arbitrary shape. Current flowing from in this direction is I. Okay, so first point that you have to understand is what is current element. If on this conductor, on this wire, I am taking one small element. I am taking one small element like this. Yes, it is very small. It is very small element. Okay, of length dl. Of length dl. Clear? So obviously, current flowing from this element is also I. Current flowing from this element is also I. Okay, so if I multiply I with this current element, it becomes IDL. It becomes IDL. Okay, and it is in this direction because current is flowing in this direction. Clear about this? So, one element having length dl, current flowing from it is I. Then this IDL is called current element. IDL is called current element. Is called current element. Clear about this? Yes, it is called current element. Now what is question? Magnetic field due to current element. So due to this element only we have to find magnetic field. So I want to find magnetic field at this point P. So first of all, from this point, okay, from this current element, draw position vector. Draw position vector. Let position vector is in this direction. It is position vector, or yes, you can say displacement vector. It is in this direction. Clear? So angle between them is lag theta. Again, due to this current element ideal, we have to find magnetic field at point P, having position vector R. Angle between ideal and R is theta. So yes, write each and everything. Okay, at point P, position vector is R, or we can say distance is R. We can say distance is R. Yes, this distance is R. Its magnitude is R. What is theta? Angle between ideal and R. Angle between ideal, that is current element, and R, that is position vector, is theta. So remember what is theta? Theta is angle between ideal and R. Then yes, Biot, after numbers of experiments, suggested that at this point magnetic field produced depends on first current flowing from conductor, second length of element, and third one is distance. Now how they depends? Magnetic field depends on current, length of element and distance. But how? What is the relation between them? So yes, Biot suggested that magnetic field at a point, magnetic field dB. Why dB? How I am writing dB? Because it is due to one element. It is due to one small element. That's why I have to write dB. Okay. Okay, so dB is proportional to I dl cross R upon RQ. Yes, it is suggested by Biot. Okay, magnetic field produced at a point depends on current, length of element, distance, like this. Clear? Now you know cross product. What is cross product? A cross B is equal to AB sin theta. Then how to simplify this? You see, dB is equal to how to find its magnitude? dB is equal to it is I dl. dl and R. I dl and R. What is angle between them? Sin theta. Then this I can write I dl R sin theta divided by RQ. So mode of dB, okay, is equal to, or I can write mode of dB, or I can write this only as dB is equal to I dl R upon RQ, means I dl sin theta upon R square. So yes, this equation you have to remember. Okay, if it is one current element having current I, length dl, it makes angle theta with position vector, then at this point magnetic field dB is equal to I dl sin theta upon R square. I dl sin theta upon R square. Understand each and every term. I, current flowing from element, dl, length of element, theta, angle between I dl and R is distance, Yes, it is magnitude. How to find its direction? With the help of right hand screw rule or with the help of right hand rule. Yes, it is magnitude. It is magnitude. How to find direction? Okay, how to find direction? Okay, direction you can find with the help of right hand screw. Now see here. We have one point to be noted. If we remove proportionality, we have to add some constant. Yes, we have to add some constant. It is the term simplified. If we have to remove proportionality, then we have to add some constant. Which constant? See how to write. If I want to convert this proportionality, I can write like this. dB is equal to, it is mu 0 upon 4 pi I dl cross R upon RQ. I dl cross R upon RQ. If proportionality we remove, then we have to put one constant. So yes, mode of dB is equal to, it is mu 0 upon 4 pi I dl R sin theta upon RQ. dB is equal to, it is mu 0 upon 4 pi I dl sin theta upon R square. So yes, you have to understand this equation. Again, magnetic field depends on current, length of element and distance. So dB is proportional to I dl cross R caret upon RQ. If we remove proportionality, we have to add some constant. That constant is mu 0 upon 4 pi. That constant is mu 0 upon 4 pi I dl cross R upon RQ. Clear? Now how to find its magnitude? Is equal to mu 0 upon 4 pi as it is I dl R sin theta upon RQ. I dl R sin theta upon RQ. So dB is equal to mu 0 upon 4 pi I dl sin theta upon R square. You have to remember this equation. Clear? Where what is mu 0 upon 4 pi? Mu 0 upon 4 pi is constant of proportionality and its value is 10 raised to minus 7. Its value is 10 raised to minus 7. Its unit is Tesla meter per ampere. Now yes, you know what is 4 pi. You may ask me one question, sir, what about mu 0? What is mu 0? Mu 0 is called permeability of free space. Now what is mu 0? What is permeability? Yes, remember first chapter, epsilon 0. Permittivity of free space means these characteristics that affects electric field. Here it is mu 0. Permeability, it affects magnetic field. Yes, simple. Clear about this? Okay. So yes, it is Biot Savart Law. do not forget to write proportionality constant. Yes, whenever you remove proportionality, you have to add a proportionality constant. You have to add proportionality constant, and that proportionality constant is mu 0 upon 4 pi. That proportionality constant is mu 0 upon 4 pi, where mu 0 is permeability of free space. Clear about this? Yes, you have to remember this equation. dB is equal to mu 0 upon 4 pi, that is constant. I dl sin theta upon r square. I dl sin theta upon r square. Clear about this? Now what about direction? How to find direction? See, dB is equal to, see this equation. dB is equal to mu 0 upon 4 pi I dl cross r. I dl cross r. I dl, and it is r. You know that whenever there is vector product, its resultant is perpendicular to plane of two vectors. So yes, here I dl it is in this direction. Yes or no? Yes. R is in this direction. Yes. This thumb is moving perpendicular inside. Again, first vector is ideal. So put your right hand in direction of ideal. Another vector is R in this direction. So wrap your fingers like this. Yes or no? Yes. Thumb is going perpendicular inside. Then yes, at this point magnetic field is perpendicular. At this point magnetic field is perpendicular inside. Clear about this? Clear about this? Any doubt? Okay, so it is magnitude and how to find direction Okay, okay, see, observe this equation. dB is equal to mu 0 upon 4 pi I dl sin theta upon r square. Yes, inverse square dependence. Okay, so it is one theory based on how due to this current element magnetic field is produced. If you want to find what is resultant magnetic field at this point, you do whole wire. What you have to do? You have to take small elements, find magnetic field due to each and every element, and find the resultant. Clear about this? Okay. Now we will see some similarities between Biot law for magnetic field and Coulomb's law for electrostatic field. So yes, some similarities between Biot's law for magnetic field and Coulomb's law for electric field. What is similarities between them? First point that you have to remember, yes, both are long range force. Because what is Coulomb's law? 1 upon 4 pi epsilon 0 q1 q2 upon r square. What is Biot's law? dB is equal to mu 0 upon 4 pi I dl sin theta upon r square. Both are inverse square law. So yes, both are long range force. What is the difference between long range force and short range force? Long range means force it is acting up to a large distance. Short range means it is in some limited region. Okay, so yes, both are long range force because they both depends on inverse square of distance. Okay, that is proportional to 1 upon r square. Clear about this? Okay. Second point is about source. Yes, electric field is produced due to charge. Which is scalar quantity. Yes, you know this. Electric field is produced due to charge, and charge is scalar quantity. While magnetic field is produced due to current element. Yes, element IDL, direction of DL depends. So yes, its source is vector. Clear about this? So yes, it is about source, electric field, source is charge, scalar, magnetic field, source is current element or vector, or magnetic field is also produced due to some intrinsic magnetic moments that we will study in chapter number 5. Okay, now third point is about direction. Third point is about direction. What about direction? See, we know that due to positive charge, electric field is radially outside. Due to negative charge, electric field is radially inside. Means it is in direction of position vector. In direction of position vector or in opposite direction of position vector, if you remember. Okay, suppose it is charge Q. At this point, if I want to find direction of magnetic field, okay, and it is positive charge, then at this point direction of electric field is in this direction. See, on this position vector, in direction of position vector. And if it is negative charge, this electric field will be in this direction. Means it is along position vector. It is along position vector. Why? In case of magnetic field, see here, in case of magnetic field, R is in this direction. R is in this direction, position vector. And magnetic field is perpendicular to it. Magnetic field is perpendicular to it. So yes, remember this third point about direction. Electric field is along position vector, while magnetic field is perpendicular to position vector. Clear about this? Clear about this? So yes, it is all about third point. That is about direction. That is about direction. Clear about this? Fourth one, angle dependence. Angle dependence. What is meaning of angle dependence? Remember equation of electric field? Due to point charge, E is equal to Q upon R square. Due to numbers of point charges, due to long straight wire, due to shell, due to infinite plane sheet, due to conductor, in each and every equation there is no theta. That is no theta. But in equation of magnetic field, yes, there is theta. So yes, according to Savart's law, that magnetic field depends on angle. Angle between ideal and R. Angle between ideal and R. Suppose, see here in this case, if I want to find magnetic field at this point, then what happens? You have to draw position vector. See, from this point, if I draw position vector in this direction, let it is point 2, let it is point 2, then what happens? See, from this ideal current element, draw position vector. See, ideal and R, they are in same direction. Ideal and R, they are in same direction. So what is angle between them? 0. Sine 0, 0. Magnetic field at this point, due to this current element, is 0. At this point, magnetic field is 0. Clear about this? Only due to this current element. Yes or no? Yes, it is. So yes, magnetic field depends on angle. Clear about this? Okay. Last point, that is number 5. That is one relation. See, epsilon 0 is equal to, epsilon 0 into mu 0. Epsilon 0 into mu 0. Epsilon 0. How to write this epsilon 0? Yes, you know one relation. Okay, K is equal to 1 upon 4 by epsilon 0. 1 upon 4 by epsilon 0. Yes, you know this relation. Then make epsilon 0 as subject. It is 1 upon 4 by k. It is 1 upon 4 by k. Then yes, it is 1 upon 4 by k. Okay, mu 0. Yes, mu 0. If from this equation you make mu 0 as subject, then mu 0 is 4 pi into 10 raised to minus 7. 4 pi cut, 4 pi cut. Yes or no? Yes, it is. Students, you know what is value of k? Is equal to 9 into 10 raised to 9. Yes or no? Yes or no? Yes, it is into. If I write this 10 raised to minus 7 in denominator, it is 1 upon 10 raised to 7. Fear about this. 9 and 7, it is 16. So yes, it is 1 upon 9 into 10 raised to 16. Clear about this? Clear about this? 1 upon 9 into 10 raised to 16. 9 into 10 raised to 16 means I can write 3 into 10 raised to 8 square. See how it is 1 upon 3 into 10 raised to 8 whole square. 3 into 10 raised to 8. Yes, you know, it is a speed in vacuum. It is a speed in vacuum free space. Yes or no? Yes, it is. Then I can write it as 1 upon c square. 1 upon c square. So what is relation? Epsilon 0 mu 0 is equal to 1 upon c square. And yes, it is one important result that relates electricity with magnetism. Electromagnetism. Clear about this? So yes, it is theory. What is Biot-Savart law? If you are asked one question, that is right, Biot-Savart law. What is direction and magnitude for 2 marks? You have to write here. You have to write F2 here. Yes, this question you will be asked as different question. Okay, what is similarities between Biot-Savart law and Coulomb's law for electric field? So yes, you have to write these 5 points. See, this third point and fourth point, you have to write in detail from your textbook. You are given one paragraph. Okay, so yes, you have to remember these 5 points. Clear about this? Now we will see some questions. See, here it is. One element having length delta L is equal to delta x sign. You see this current element is in positive x direction. Placed at origin, okay? Current flowing from its I is equal to 10 ampere. What is magnetic field on y-axis? The distance 0.5 meter. Delta x is equal to 1 centimeter. Yes, you are given 1 centimeter. Okay, see how to find it. First of all, let x-axis, y-axis, origin. Element delta L is placed at origin. It's placed at origin. Yes, it is placed at origin. And its direction is in this direction. See, delta xi. Yes or no? Yes, it is. So yes, it is element delta Lx. So how to write element? See, I am writing like this. Okay, dl is equal to delta x is equal to, what is the value of delta x? Delta x is equal to 1 centimeter. This is 1 centimeter. 1 centimeter is equal to 0.01 meter. Clear? Current flowing from it is I is equal to 10 ampere. Yes or no? Yes. What is magnetic field on y-axis at a distance 0.5? It is y-axis. Suppose it is point P, where we have to find magnetic field. Distance r is equal to, it is 0.5 meter. So first of all, you have to draw position vector in this direction. Yes, it is position vector r. It is center. Yes or no? See, from figure it is clear. Ideal current flowing from this is I. Ideal, it is in this direction. Ideal, it is in this direction. Position vector is in this direction. What is angle between them? 90. So yes, here theta is equal to 90. Here theta is equal to 90. And yes, you have to find magnetic field. dB is equal to mu 0 upon 4 pi I dl sine theta upon r square. Yes. Yes. Mu 0 upon 4 pi 10 raised to minus 7. Mu 0 upon 4 pi 10 raised to minus 7. I 10 dl 0.01 sine theta means sine 90 is this one. R is 0.5. You can easily find what is magnitude of magnetic. Now what about direction? What about direction? How to find direction? How to find direction? What is vector equation? Vector equation is equal to mu 0 upon 4 pi I dl cross r upon r cube. Remember this point, r cube. Okay. So see, first vector is ideal. Yes, it is ideal. R is in this direction. Then thumb is perpendicular outside. Thumb is perpendicular outside. Again, ideal this direction. Wrap fingers towards R. Thumb outside. It is x, y. Z axis is perpendicular outside. And yes, direction is in Z direction. Correct. Along Z axis. Along Z axis. Clear about this? Along Z axis means coming outside. Coming outside means, sorry, at this point, coming outside. Clear? So yes, it is one question. Yes, you have to remember how to find angle between ideal and R. How to find angle between ideal and R. Clear? Now next question. See. Example 4.1. You are given one wire having mass 200 gram, length 1.5 meter, current flowing from it is 2 ampere. It is suspended in mid-air by magnetic field. What is magnetic field? See, it is suspended in air. Now, how is this possible? Yes, if I have this charge in only gravitational field, then there is only one force, mg. That is weight, that is always in vertically downward direction. Yes or no? But it is suspending, it means there is some another force which balances this weight, So yes, here same thing, here on this wire, gravitational force, Fg, it is acting in vertically downward direction. Fg is acting in vertically downward direction, gravitational force. But current is flowing from this wire. Magnetic field is given perpendicular to this plane. Then due to this magnetic field, magnetic force is acting on this wire. In which direction? See, again, remember equation ideal. What equation of force? Equation of force. Equation of magnetic force. Equation of magnetic force. Equation of magnetic force. Fm is equal to IL cross B. IL cross B due to long straight wire. Okay, it is IL cross B. Clear about this? Yes, it is equation of magnetic field. IL in this direction. Magnetic field perpendicular inside. Do you understand? Current in this direction. See, magnetic field inside. Graphing field in this direction. This thumb is in this direction. Means on this wire, magnetic force is acting in upward direction. See, these two forces are in upward direction, and as it is suspended in mid-air, it means sigma F, resultant force acting on it is 0, and resultant force acting in 0, it means both force having same magnitude and opposite direction. Yes, opposite direction we have proved. If they have same magnitude, they are equal in magnitude, then and then the resultant becomes 0 and this wire becomes stationary, suspended in mid-air. Okay, otherwise, if this force is larger, it will move in downward direction. If this force is larger, it will move in upward direction. But if two forces are equal in magnitude, it will suspend in mid-air. So yes, Fg, what is the equation of Fg? It is mg. What is magnetic force? Its magnitude. It is ILB. Sine, what is angle between I and magnetic field? I is in this plane. Magnetic field is perpendicular inside. So angle between them is 90. And yes, we know what is value of sine 90. Sine 90 is equal to 1. Then mg is equal to ILB. From this equation, make B as subject. Make B as subject. Then B is equal to, it is mg upon IL. It is mg upon IL. M, 200 gram, convert in kg. G, yes, you know its value. I, given. L is also given. Yes, you can easily find its value. Clear about this? Okay. Next question. Example 4.2. X, Y and Z. See X, Y. Y-axis is perpendicular inside. Again, Y-axis is perpendicular inside. See, magnetic field is parallel to Y-axis. That's why I have denoted by cross. Yes or no? Yes. Magnetic field is parallel to Y-axis, means it is perpendicular inside. Particle is moving along x-axis, means velocity is along x-axis. Your question is, what is direction of force on proton and electron? On proton and electron. First of all, for proton. See, what is equation of force? See, F is equal to Q V cross B. Q V cross B. Okay. So yes, for proton. Proton means positive charge. Proton means positive charge. See, force is in direction of V cross B. See, here it is. V in this direction. Magnetic field is perpendicular inside. V V in this direction. See my right hand in direction of V. Magnetic field is perpendicular inside. So wrap your fingers towards magnetic field's direction, means inside. This thumb indicates direction of force. This thumb indicates direction of force. Clear about this? Again, F is equal to Q, V cross V. V, proton is moving in this direction. Magnetic field is inside. So wrap your fingers. Then thumb gives direction of force in this direction, means parallel to Z. Means yes, force acting on proton is along Z axis. Is along Z axis, positive Z axis. And say, dear students, what is the equation? F is equal to Q V cross V. Charge of proton is positive, while charge of electron is negative. Is negative. Yes, force will be in opposite direction. Force will be in opposite direction. Okay, so yes, you can write your answer directly. If force acting on positive charge is along the positive Z axis, force acting on negative charge is in opposite direction. Is in opposite direction. That is along negative Z axis. With the help of this equation. With the help of this equation. Clear about this? So yes, in this equation you have to write like this. Okay, with the help of this equation, direction of force acting on proton and on negative charge, it is in opposite direction. Yes, magnitude varies, but direction, positive charge and negative charge, it will be in opposite direction. Clear about it? Right.